I think it's time. I really think it's time. And I also think that I have very low sensitivity on this microphone. Because last time I rewatched what I streamed and I was not happy with the level. I guess we can do a little bit better when I'm away from the microphone. Because if I'm very near, everything's fine though. So, welcome. Let me change the scene. Also, I think the volume of the music is kind of high. No, shouldn't be. Well, it's high to me, so I will just drop it a little bit. Change the scene. And we are on Spotify. Here we are. So, as I said, tonight we're gonna start a little bit. I say tonight, probably it depends on where you are in the world. It may be full day now, but HSVSphere here published a post on I'm gonna call it Twitter because X. I'm still not used to that. And was wondering about a way to reset the entire CSS, so to style everything from scratch, that it must be small, does not try to attempt to support Explorer, all the arcane garbage, literally what he or she wrote, and then came out with this solution. Star all unset, style and script, display none. And I have first of all to understand why everything is needed. And also there were people saying in the comments that let me see. Slug37 said that we should be aware of all that it undoes, and I gave a look to this post, and there is some pretty critical stuff that goes on when you touch the CSS this way. And also Fabio Spampinato, which may or may not be a fellow Italian, says that if nothing changed, and he remembers correctly, all unset is super slow, which I am interested in, because if it's super slow, we don't like it. We have to find another way to achieve the same result. This music is annoying me a little bit. Let's try the next one. Well, maybe better. There are no other responses, so strange, because I remember posting. Oh well, probably I posted by myself. So first of all, let's do some parallel research, how to unstyle a page completely. Remove all browser defaults. First of all, how to set remove CSS type for a specific element, or okay, there's probably 2 people here speaking about this. So a good use example might be in a mobile-first RWD site where much of the styling used for a particular element in the small screen views needs resetting or removing for the same element in the desktop view. A CSS rule that could achieve something like element all none. So we could quickly remove or reset styling without having to declare every property. The way to do it is to restrict it in the first place with media queries. There is a property called all that is being proposed for resetting all CSS properties for a given element to certain CSS-wide values. The value you want to use would be unset, which resets a property to either its inherited value if it inherits by default, or otherwise its initial value. No word on implementation, but it's nice to know somebody has thought of it. Here is a 2015 tweet to that effect. As defined in the spec, the all keyword has a broad browser support except for the IE and Opera Mini families. Since IE's lack of support may cause issues, here are some of the ways you can reset some CSS properties to their initial values, and there's just a lot of stuff here. So relevant GitHub repo, more exhaustive list, related from MDN, related W3C specs. With all that said, I don't think a CSS reset is something feasible unless we end up with only one web browser, if the default is set by the browser in the end. I think this is correct in principle, but individual mileage may vary. For example, certain elements like text area by default have a border. Applying this reset will render those text areas borderless. So it's not a true reset. I ended up using it for only certain properties which I cared about. You can also combine it with the star selector to reset all elements or reset all elements inside a specific element. Applying this with the star selector will kill your browser and a kitten. Why though? This is not a true reset. True reset just doesn't exist. You can use the all property. You do not want to ever use the initial like this. This will erase most web browsers' default UA style sheet for the element, which means things like block level elements will now use display inline, etc., etc. Most web developers do not understand that most elements have no styling until a default user agent style sheet that comes with browsers is applied. This sheet is what gives elements a base style before the author applies their own styles over it. If you use initial, you erase all styles and cannot get the element style back on your web page for the viewer. And we're very well aware about that. Of it. The revert keyword works exactly the same as onset in many cases. The only difference is for properties that have values set by the browser or by custom style sheet created by users set on browser side. You need a CSS rule available that would remove any styles previously set in the style sheet for a particular element. So if the element have a class name like remove all styles, all revert, this will reset all styles, all styles applied by another class, and all other inherited and applied styles to that div. So this one resets the style that we applied, but keeps the stuff that the browser added to the component. All author styles, yeah. Okay, so this is different from a nuke, different from the nuke we were looking for. I really don't like this playlist. It's too agitated. What about this? I think it's better. Let's see if I have some notifications here. Yes, nothing new. Yeah, there is something new. Okay. So, here it says predefined keywords. In the value definition fields, keywords with a predefined meaning appear literally. Okay. Initial, inherit, and unset. As defined above, all properties accept the CSS-wide keywords, which represent the values computed. Okay, this is getting a little bit deep, and I don't think it's the thing we wanted to see. Opera Mini is still the the one that's not supporting initial. Same goes for Internet Explorer. We kind of don't care. What's Opera Mini, by the way? I never encountered it. Opera Mini. Mobile web browser made by Opera. It was primarily designed for the Java ME platform as a low-end sibling for Opera Mobile. But as of January 2025, only the Android and Mocha OS builds were still under active development. It had previously been developed for iOS, Windows 10 Mobile, blah, blah, blah. Okay, so we really don't care about it. Going back to the original, no, not here, tweet on x.com. Where is it? My profile. And here we are. I thought, okay, it's here. Don't use all unset for CSS reset. I thought I'd try my hand at using all unset for CSS reset. Turns out it's more trouble than it's worth. The reason is that browsers all have their own vendor-specific properties to achieve baseline behavior, and by unsetting everything, you break basic functionalities. For example, all unset on the HTML element in Chrome will break hyphenation, which can only be restored via WebKit locale n. In addition, you will have to steer clear of SVG, audio, and video elements. Okay. The conclusion is the vendor style sheet does many things to achieve that unstyled look, and unsetting all of them causes you more headaches than it solves. Will not set an hyphen in Chrome. This happened because of a bug in Chrome when resetting the main HTML element. What do they mean by hyphenation? That CSS hyphens. Okay, specifies how words should be hyphenated when text wraps across multiple lines. It can prevent hyphenation entirely, hyphenate at manually specified points within the text, or let the browser automatically insert hyphens where appropriate, which is also kind of newly available as baseline 2023. So, okay, this carries no different here, but hidden shy soft hyphen s high character, an extraordinarily okay. So when you use manual, it uses this character. When it does not use, when you are on auto, it will try to hyphenate wherever happens. So this thing is broken when you unset everything, right? Which is exactly what HSVSphere was proposing. Why I'm not following? Follow. So let's say we create a new. Is this thing not working? Yeah, it's completely broken. Why is that though? Okay, Docker desktop. That should not. I don't need this actually to test anything, but yeah, well, I don't need it actually, so we will not rely on that. What's going on with my keyboard here? This terminal, I feel it's completely doomed. Yeah, I will just go and start another one. There are all the strange bugs that you can possibly imagine in the WSL terminal here on Windows, if you have WSL in a terminal here on Windows. Come on. So slow. Come on, man. I don't have all day. I literally don't know what is it doing. Resource saver mode, this guy here. What? Yeah. Let's say we do it here. So touch CSS nuke.html. CSS nuke.html. So any page will do. Should be doc type, right? Doc type HTML. Is it? And head and body, and the head will also have its closing tag, and so will the body. Let me just check if I'm right, because I don't do that. I always copy paste it from somewhere else. So no, not here. CGI bin index. Yeah, I got that right. I can add the language though. Lang and US, for example. And let's say I write CSS nuke test. Maybe it's better if I zoom in a little bit. Nuke test and introduction. I just noticed that I have to do this because I can't see the chat otherwise. Okay. Introduction. Test paragraph. Also a little bit of lorem ipsum. $sit Ahmed lol. I'm joking. I don't remember any more of that. Let's say we just have this, and here we open a style tag and write that all unset. Let's see what happens. Well, actually, I could do this and this so that I can check X. Okay. Where were we? Well, we are. Oh God, yeah. I did that, but I didn't consider that I should go and open the file from here. Let me see. Yeah, open. Yeah. Make me happy. There's something wrong here. I didn't close the style tag, didn't I? I did close the style tag, so what's wrong with you? The easiest things are also the most difficult ones, because you do them like never, and they always find a way to break everything. Well, yeah, you can stay there, and I will just move the style on the right. Here the title can be CSS nuke test. I don't need a description really, so to do. And what about you now? I don't understand why it's printing the style inside the, probably because head. No, well, wait a sec. If I remove this, what happens? What did I do here? Oh god. Okay. Yeah, and that's the first problem. And that's the first problem. Because why are you doing this to me? I don't put the focus on this page, please. Where is the rest of my browser here? Here. So, please, would you be so gracious and inspect here if I press F12. Look at this. Is there any way to see all the style that we have for the particular page? Chrome DevTools, see the whole style applied to a particular page. I don't want to see the single elements. I want to kind of see the entire spreadsheet. I feel like even if I don't like it, this is where our guy here can help us. Totally unrelated question. Is there any way to see in Chrome DevTools or any other browser web DevTools for that matter, the entirety of style rules applied to a particular page, as if all the styles for all elements, classes, etc. were I don't even know if coalesce is the right term, but condensed, yeah, condensed into a single CSS file for me to read. Retry. Yeah, okay. Let me. Mr. Chat GPT, can you please help me? No, stay logged out. Stop interfering. That's a great question. Yeah, you didn't have to have an opinion about that. Well, browser DevTools don't give you a literal all styles condensed. There are a few ways to approximate this. Yeah, sure. Why having something useful when you can have an approximation that doesn't do? By definition, the approximation is not what I'm looking for. Here's how you can approach it. Option 1: view all loaded style sheets. Manual aggregation. Yeah, but the actual problem is I need the original authored CSS. I don't need the authored CSS only. I want to see the user agent CSS 2. Coverage, reload. Chrome will show you which styles are used and unused. Yeah, I don't need it. Computer styles relevance. Use a bookmark of the script to extract all styles. Well, but we actually don't need all that I said because we are just. I just need the user agent style sheet. So, how can I see the user agent style sheet? Then, great follow-up. Thank you very much. So, this is what we are unsetting the moment we use unset all, and you can see that I'm very curious. This is just for Chrome, by the way, because Firefox and Safari will all do different stuff. Table, t-head, t-body, t-foot, table. I'm scrolling just to see if anything catches my attention, but also I'm kind of curious about the style, because as you saw before, unless I did something wrong, which is perfectly possible, when I added the style here, please, would ya? No. Why though? Why though? Why did you freeze again? Oh my god. Tonight is not our night. At least it seems like that. I mean, if I'm writing here, yeah, it's writing. So, what's wrong with you here? Why did you freeze? Oh shit. Sorry for swearing. No way. No way. Well, I mean, I really have to take my time and set up another machine with Linux, because Windows became... Look, it's totally unbearable. It's totally unbearable. I have no words for it. I'm just sad and desperate for a solution. No, man, I want to add... Yeah, okay. I want to edit it. Can you give me the possibility to choose another app? More apps. Notepad. Okay, here we are. So, because if nothing else works, I will have to go like this. Let's say we change the font size of H1 to be 50 pixels, 100 pixels. We want it to be very, very big, very, very big. Is it gonna work or is it not? It's working. So there was nothing wrong here. Okay, it's just that when you unset everything, which was exactly the way, yeah, Style script is okay. Yeah, right. and that's exactly what we were missing. Style script, style script, display none. Okay, fine with that. That's supposed to work. That's supposed to work. So we are now at a base point. Let's see here. Not only style, this guy here is the title. So let's explore this and see if style appears here. Yeah, you can see that it's not only hiding style and script, but also base font, data list, head, link, meta, no embed, no frames, param, RP, script, style, template, title, which is the first thing that this solution here does not do. This doesn't work. It needs more. It needs more. Also, then we should understand what in this sea of defaults is actually needed, because, and now we will experiment a little bit with what others pointed out to be problematic, because there could be something in here that oh well, yeah, also look at this calendars. Okay, so if you nuke everything, then some things that you might expect to be working out of the box, and you want them to be working because you want to rely on the I mean, I want to rely on some components sometimes when I program something in the browser, so that I don't have to style them from scratch. And thank you. And you know, make everything from scratch. They're there, they work. I just declare them, they come up, everything's fine. So those are to be explored too. WebKit meter even less good. Well, okay, that's kind of dark suddenly. Let me turn on this light so that I'm, yeah, better. Don't, thank you. Progress, see. But I see. Probably I'd rather individuate which are the components that are more often than not troubling me. So buttons, anchors, titles, paragraphs, divs, stuff like that, and nuke just them and restyle them. But if we still want to go down this route and find out if anything else is broken, we could probably well, let's see. Let's say we also add head, link, meta. Well, let's copy every one of them over. Okay. Okay. Another problem we have here is that some defaults to me are good, because if display is not blocked, what's the computed style here for it? Display inline. You see, an H1 is in line. Okay, this may not be the end of the world. Font size to be unset is kind of fine. Margins are very, very well. I like them to be unset. Font weight, bold. Okay. What's Unicode BD? Unicode BD. Bidirectional. Determines how bidirectional text in a document is handled. For example, if a block of content contains both left to right and right to left text, the user agent uses a complex Unicode algorithm to decide how to display the text. The Unicode bidirectional property overrides this algorithm and allows the developer to control the text embedding. Okay. Don't care. Then, if we want to have a clue about the performance, how to measure CSS performance, because I'm not an expert. I'm not even a beginner in that. But luckily enough, I have many clues about performance measuring. Many, I mean, working knowledge. So we can start from there and find a way to get the answers we need. When developing a website, you need to consider how the browser is handling the CSS on your site. To mitigate any performance issues that CSS might be causing, you should optimize it. For example, you should optimize. No engineer does this today. For example, you should optimize the CSS to mitigate render blocking and minimize the number of required reflows. This article walks you through the key CSS performance optimization techniques. And that I know. Yeah, okay. What do I need to optimize? Measure the performance of your site. Don't tell me. Okay. Yeah. Yeah, and that's kind of lighthouse for Chrome. Network monitoring tool, performance monitor tools. Yeah, here we are. You can also use browser performance tools such as Firefox Performance Monitor to measure the performance of a web app or site's user interface as you perform different actions. This indicates the features that might slow down your web app or site. Firefox Performance Monitor. We will have to start up. I don't want to start up Firefox. Let's see some documentation about Chrome performance monitoring. Analyze runtime performance. Here we are. And I also eat some popcorn. What's the Rail model? Response animation idle load. Okay. Control Shift E. Oh, really? DevTools, Performance tab. Yeah. Screenshots checkbox is enabled. Capture settings. What? which is this. Okay. CPU 4 times slowdown. Okay. When testing other pages, if you want to ensure that they work well on low-end mobile devices, set CPU throttling to 20 times slowdown. This demo doesn't work well with 20 times slowdown, so it just uses 4 times slowdown for instructional purposes. It's hard to create a runtime performance demo that works consistently for all readers of this website. Oh, so they're doing this here. Okay. They are doing this here. It's a keep clicking add 10. This section lets you customize the demo to ensure that your experience is relatively consistent with the screenshots and description you see in this tutorial, regardless of your particular setup. Where is it? Where? Oh, this one. Okay, sorry. I just skipped the part. This one is the one. So they said like this. Performance throttling 4 times slowdown. Very nice. And so here we don't need it. And what they said is keep clicking add 10 until the blue squares move noticeably slower than before. On a high-end machine, it may take about 20 clicks. Don't know if this is considered a high-end machine. I don't think so. 1, 2. Yeah, no, definitely not. Okay. Click optimize. The blue square should move faster and more smoothly. Yeah, not really. If you don't see a noticeable difference between the optimized and unoptimized version, try click subtract the... Yeah, well, there's a difference, but maybe this is better. If you add too many blue squares, you're just going to max out the CPU and you're not going to see a major difference in the results for the two versions. Click unoptimize. The blue squares move slower and with more jank again. Record runtime performance. When you run the optimized version of the page, the blue squares move faster. Why is that? Both versions are supposed to move each square the same amount of space in the same amount of time. Take a recording in the performance panel to learn how to detect the performance bottleneck in the unoptimized version. So in DevTools, click record. DevTools captures performance metrics as the page runs. Then you wait a few seconds. You click stop. DevTools stops recording, processes the data, then displays the result in the performance panel. Wow, that's an overwhelming. Okay, let's do that. Record. We'll let it run for 10 seconds. 8, 9, 10. Loading profile received. Here we are. Oh, it's even screenshotting everything. Okay, let's see. Once you have a performance recording, you can analyze just how poor the page's performance is and find the causes. The main metric for measuring the performance of any animation is frames per second. Users are happy when animations run at 60 frames per second. Look at the FPS chart. Whenever you see a red bar above FPS, it means that the frame rate dropped so low that it's probably harming the user experience. And here, it's definitely showing that. Below the FPS chart, you see the CPU chart, which is this one. I guess it's the, yeah, CPU. Here on the top right of the screen, it says CPU. So the wobbly blue, purple, and orange and gray graph is the CPU. My computer is melting. Yeah. I could even stop it here. Yeah. Below the FPS chart, you see the CPU chart. Yeah. Okay. Whenever you see the CPU maxed out for long periods, is a cue to find ways to do less work. The fact that the CPU chart is full of color means that the CPU was maxed out during the recording. So yeah, did not happen actually. But the gray part actually it was happening, because the black on the you can see here on the top left. I mean, I'd like to have this part of the graph a little bit bigger, but okay, you can zoom in. Okay, fine. You can see here on the top left that there's black, the same black of the incognito background here. So it's actually maxed out, and the dark gray here says it's system. So it has been to the max for all the duration of the test. Hover your mouse over the FPS, CPU, or net charts. DevTools shows a screenshot of the page at that point in time. Move your mouse left and right to replay the recording. This is called scrubbing, and it's useful for manually analyzing the progression of animations. In the frames section, hover your mouse over one of the green squares. DevTools shows you the FPS for that particular frame. Each frame is probably well below the target. Oh yeah. No, it's not here. Where is it? Frames. Ah, here. Partially presented frame. Is it here though? Why? Oh, okay, you can open it. Yeah. I still don't. Oh, okay, you can zoom in. So it's no. This is. I mean, where are the green? Give me a sec. No, not here. In the frames section, hover your mouse over one of the green squares. Do you mean, yeah, these ones? But here it's reporting the duration of a frame. On the other hand, here it says that it shows the FPS, and it's not true. FPS for that particular frame. Is it referring to okay, no. This thing should refer to this image. So over your mouse. Yeah, and it's hovering on a they say one thing and they write another one here, but well. It's pretty obvious that the page is not performing well, but in real scenarios it may not be so clear. So having all of those tools to make okay. FPS meter, which provides real-time estimates. Control Shift P. I still go to the wrong place. So start Control Shift P. No, not true. You're telling me lies. To open the no, okay. It was right. Start typing rendering. They can't show rendering. Okay. Show rendering. Yeah, I mistyped rendering. And well, it's this one here. Enable show rendering stats. Enable show rendering stats. Where is it? Where are you? It's frame rendering stats. It's not even 30. Then disable the FPS meter and press escape to close the rendering panel. You won't be using it in this tutorial. Okay. Sorry, man. Gotta go. Find the bottleneck. Now that you've measured and verified that the animation is not performing well, the next question to answer is why. Note the summary tab. When no events are selected, this tab shows you a breakdown of activity. The page spent most of its time rendering. I don't think this is well. I got into this, and so I was gonna finish it, but I don't think it's what we need. Rendering takes a lot of time. Yeah, if I go and see my situation here, is there a way to see the same diagram they saw or not? I'm guessing or not, because I don't have any way to I keep, well, let me just do something, because I want to alt tab to this other yeah, tab, and it's getting on my nerves. The summary here says we should have a pie diagram, but we don't, and I don't know why would they remove it. Notice when this shows you a breakdown of activity. Did I select anything? No, I'm not. I didn't select anything. So, boop. Impossible to know. Still, we can see that rendering is the winner here. They are in order. Expand the main section, which is this one. Yeah, it's already expanded. DevTools shows you a flame chart of activity on the main thread over time. The x-axis represents the recording over time. Each bar represents an event. A wider bar means that the event took longer. The y-axis represents the call stack. When you see events stacked on top of each other, it means the upper events caused the lower events. So this cause this cause this. Okay. Zoom in on a single animation frame fired event by clicking. Okay. So you could just click. No, you can't. Clicking, holding, and dragging. Dragging to your mouse over the overview, which is the action that includes the FPS, CPU, and net charts. Here we have this. I have to click the event And drag it where? The overview. So up here? No. Well, guys, let's say I do this, okay, for any event. Note the red triangle in the top right of the task and layout events. The top right of the task and layout events. Task is this, and there's a red triangle. There are no layout events. Oh, these are layout events. Yeah. Whenever you see a red triangle, it's a warning that there may be an issue related to this event. A red triangle on a task means it was a long task. Click the animation frame fired event. Animation frame fire. Yeah, I clicked it. So what? Clicking the link next to the initiated by. Which I don't see. Because DevTools to highlight the event that initiated the animation frame fired event. No, where is the mouse in this picture? This is selected. Initiated by, look at this. Animation frame requested, initiated by. Nope, guys. Maybe this. Because the task has this, but animation frame fire does not have the triangle. It does not have the triangle here too, so that's not the problem. Clicking, holding, drag, yeah, okay. Jumps to the relevant line in source code. I really like that. I'd really like that. Well, it says something here, but it's different from what it used to be. Duration is here. Self time is here. Callback ID is here. So there's a part here in the middle is missing. Is there any way to show it? No, it's not. There's not one. Let's go. Use the arrow keys to select the event next to it. Everything freezes here because my computer is breaking down. I really need to fix my other laptop. So, and a function call app update. Okay, because this one was not initiated by anyone, but this was. So you have the stack trace and the initiate. Okay, So it's different actually. Okay. And so what? Sorry, but evaluate script animation file. You see that request animation frame calls for another function call here. So okay, the line is if they were wider, it looks as though each one might have a red triangle on it. Yeah, we already noticed it, because if I unclick here, they have red triangles. Click one of the purple layout events now. Yeah, well, okay. Indeed, there is a warning about forced reflows, another word for layout. In the summary tab, click the link next to update, this one. That says that we're here, and this takes 2329.2 milliseconds, so 2 seconds and of it. DevTools takes you to the line of code that forces the layout. The problem with this code is that in each animation frame, it changes the style for each square and then queries the position of each square on the page. Because the style changes, the browser doesn't know if each square's position changed, so it has to relay out the square in order to compute its position. See avoid forced synchronous layouts to learn more. Phew, that was a lot to take in, but you now have they could have gone a little bit further and show us how to change the code, because I mean that last screenshot here tells me that m.style.top is a problem, but look at this. Not very much, is it? Not very much. So let's go here and say we open this, and still here 61.9. I mean, oh, okay. Yeah, let's do the same for the optimized version. Performance, clean everything. Everything broke again. I don't know why it takes so long. What are you doing? Okay, I'm not sure. I'm not entirely sure of what happened here, but let's do this. In the optimized, still these numbers are better, if you ask me. Ah, it was running unoptimized. Sorry. They're better not in the sense that they are less bad than before. They were just reflecting a little bit more the what I expected. Let's record it now. Here you can see the red just here, long task took blah blah blah, but the chart is completely different, and the layout part itself seems better. Yeah, well. Does much less work, resulting in better performance. Yeah, okay. Even this optimized version isn't that great because it still manipulates the top property of each square. Yeah. A better approach is to stick to properties that only affect compositing. See use transform and opacity changes for animation for more information. The foundation of understanding performance is the rail model. This model teaches you the performance metrics that are important to your users. To get more comfortable with the performance panel, practice makes perfect. Try profiling your own pages and analyzing the results. Yeah, and that's what we're gonna do. So let's say, okay, now this is incognito, so it won't. And here we have other pointers to knowledge that we don't need right now. So this page, which is the one where we nuke the CSS, we could remove this because we really don't need it. Refresh performance. What if I record and reload? I think stuff already happened here. So yeah, maybe it would be better if I did this and this, and then CPU 20 times slow down, and this. Function call profiling overhead. Yeah, nice. Then evaluate script, compile code, request idle callback, visibility change. Is there any task about? Okay, this one, long task. We don't know what it does. Recalculate style. 35.42 milliseconds. Selector says select, enable CSS selector starts slot to collect details, CSS selector matching statistics. Elements affected 8. It might be very slow indeed, because then you have the paint phase and layerize. where is it? Here, recalculate style. It is very big. Rendering 35 milliseconds, and this is 35 milliseconds. So yeah. Let's say we now do the same in oh god, in this other tab, but we do not unset everything. Let's compare the differences. This goes here, and then refresh and record. Yeah, maybe would be better if I throttled the CPU the same. Oh my god, same way I did before. So here we go. Looked faster to me already. It seems very different. Is it here? Parse HTML, recalculate style, 0.45 milliseconds, while here, look at this, parse HTML it always takes 370 microseconds, and here it is a little bit more, but the recalculate style here took 0.45 milliseconds, and here it took 35 milliseconds. Much more, much more. Enable CSS selector stats. Enable CSS selector stats. Yeah. Let's do this again. Okay, here we are. Let me do the same here, but this time we do not comment this. And we enable the CSS selector stats, 20 times slowdown, record, and reload. Let's see. Recalculate style, selector stats. Spelling error. Root H1. 0.032 match attempts, match count, percentage of slow path non-matches. Line, here it is. It's not this one though. What's wrong with you? 0.016 milliseconds totals for all selectors, and here 0.032, so double that. Totals for all selectors. What's the difference here? Spelling errors and root, kind of the same. H1. I feel I cannot trust this. This one does not look, doesn't seem very slow to me, actually. We don't have it here, but it didn't seem very slow to me. 0.42, 27, I mean, So where's the problem? It is slower, but it's not in the selector stats. You cannot see it from here because you see that the elapsed time is always, this is milliseconds, so these are all a lot less than a millisecond, and they're comparable to this, if you ask me. Here you have 16 and here we have 32 microseconds, but still pretty good. But this takes almost 30 milliseconds, while this takes less than 1 millisecond. So it's as if this was honest and did just some this, but here this is not the whole picture. There's something else. Self time, total time, loading, messaging, scripting, rendering, painting. Yeah, it's all only rendering. As if rendering in this situation was more difficult. And this is kind of a toy example. I'd like to go and see on one of my pages what's everything, how much it is influencing the thing, because it's already a lot. I mean, adding 30 milliseconds, if it's always the same, is a lot. But if you usually wait, I mean, it's 30 milliseconds, but it's 30 milliseconds when my CPU has a 20x throttling. But they say should be representative of the way a low-end mobile device works. So someone will have this experience. The problem is focusing on this only won't tell us how this impacts the performance in a context where other things are happening. Here almost nothing is happening. The page is very, very toyish. So we'll go and do the same thing here, which won't come up because I had that moment with Windows before. Just give me a sec. Just give me a sec. I could definitely close the, if I didn't already, the test page from before that was eating up my CPU, but I don't see it here, so I guess I got rid of that already. This can be closed. Okay. Where are we? No, not yet, because I didn't start the container here. So let's start that. Hopefully it will work. It started, at least if you trust him. Okay. Let's say I give it a shot to terminal. Yeah. ls cd cgi bin index. Is it index though? Oh well. Let's do this. Mvim cgi bin index. And here, before the rest of the styles, we do this, the same that we earlier did here. Oh god. Here we are, and style. And now if I move to here and refresh, everything will be completely broken, right? Kind of. Some things are surprisingly alive and well, but we now want to compare how it behaves with and without this. So let's do this, refresh, stay the way you are. We already saw that the enable advanced paint instrumentation. $20 times, refresh and start. Okay. Here, recalculate style takes 512 milliseconds. And then you have 1.33 seconds of layout. So a lot, but it's recalculate style, the one that was affected by the style. And if we do this, and go to localhost index, uncomment these lines, and do it again. So 20 times. Did I? Yeah, I did. Selector stats. Here you can see a grand total of yeah, it's a sum, but lower is better. Oh, okay, you can make selectors much better and allow it to heat more, because here you're matching 400 elements and it's trying for 1400 times, so performance goes down, rightfully. If I'm gonna do the same thing here, yeah, I think we're fine now. The evaluate script, layout, recalculate style. I'm confused. I'm really confused. Okay, there are two of them. Which one is which? This one was way before. Parse style sheet. Parse HTML. This was initiated by whom? Summary. Initiated by schedule style recalculation, which happened here. While parsing the HTML. Parse style sheet. Yeah, here it happens in two tranches probably, because no, not here, sorry, here, because something comes from the HTML itself. You can see it here, and this other part here comes from some other HTML parsing. Okay, totally different thing. So it's not the one we need and we care about. We just care about this one. Parse HTML index 0. So this. And then parse style sheet. But this is parsing inside the style sheet with index.css. Yeah, right. This means we are already after this part here. So this was caused by what on earth? Okay. Bar. Is there the star operator though? Yeah, it's here, line 14, 1. The operation itself doesn't look like this is selector stats though. It's not about the time it takes to execute unset all or something like that. This just tells you if the selector has been efficient or not. So this is not exactly we can say that here we have 791.93 milliseconds plus other 700 milliseconds. So but I'm scared that this thing here is about box categories. How many requests are there? Just one, just the one. So let me do it again and keep it for a longer time so we can compare the two a little bit better. I guess the size of this may interfere. Let me make sure this is the same size on each trial. So away, refresh and start. Okay. And here now we do the same. So like this, and like this, and we do this. Hope. And let's hope. Okay, so rendering took 2 seconds and 2 seconds and stuff, and 1/8 of a second. Here rendering took less, and it's not a good indication because the picture here is not showing, so it's very difficult to compare the two results. Render blocking requests, index.js, CSS. Oh well, okay. Network dependency, improve image delivery, optimize down, use efficient cache lifetimes. So we have to go down to the details, and the style recalculation here happens only once. I hope. Now it's happening here too. Selector stats. This is not the style sheet that we care about. This one is layout, recalculate style. Yeah. Parse HTML, parse style sheet. So after this, there is a recalculate style. This task here recalculates the style and takes there must be the star operator here. Not really, actually, because this one is the ones without the style there. So I'd say on this one, we start from this one, and here we have a massive recalculate style, which must be the one due to, yeah, this and this are the same. Okay, so here recalculate style and here recalculate style have similar or not lengths. This one is 468.23. This one has less, much less. 468.23. Then layout here is 1.25 seconds, and here layout is much less, but it's divided, it's split in two. Oh well, here too. This one layout route may be comparable to this one, I guess. Almost 400, and this is a little bit more than 400. But schedule star calculation, which is this one? Recalculate style. And it took almost nothing. Is it the same here? Yeah. Yeah, it is. This was even faster. So probably we should have some different test environment to say if that thing was actually impacting. But what I can see here is that the recalculate style is actually shorter in this page compared to this page, where in this we unset all and in this we didn't. So the slowdown was the same, right? Yeah. But probably is, even if I just look at this here we're going from 305 to, if and I'm not even sure I'm right, we go to 468, right? 305 468 is a difference of 160 milliseconds on a grand total of 3 seconds. How much? If I go from here to here, where yeah, 3 seconds. So it is 1/20th. Yeah, 1/20th, because it's more or less like this, right? Sorry. No, sorry. Which is 1/20. %. Yeah, it has an impact actually. But also here we are on a 20 times slowdown. So usually on, well, no, don't consider this machine because this machine is a desktop. So if I'm reading this right, and I don't think I am, because as I told you, I'm not an expert in this kind of stuff, and then we will find another way to check. We can ask the internet if there is some way to know whether a specific selector has an impact or not, and how to measure that. So we will try to find our way around it. But from this first analysis, looks like it impacts the style recalculation, and it's not that negligible, right? So how to measure a specific, it's not a selector, it's unset all performance. We were already here before, but it's telling us just the high level things. See, they already tell you, don't apply styles to more elements than needed. A common mistake is to apply styles to all elements using the universal selector, or at least to more elements than needed. This kind of styling can impact performance negatively, especially on larger sites. I mean, it sure does more work than before, because to reach that point, the user agent spreadsheet probably already loaded, and then it has to go and recompute the style sheet, the resulting style sheet, by unsetting everything. So it does some more work. But still. Okay. This is nice. The contain property allows an author to specify exactly what containment types they want applied to individual containers on the page. This allows the browser to recalculate layout, style, paint, size, or any combination of them for a limited part of the DOM. The content visibility property is a useful shortcut which allows authors to apply a strong set of containments on a set of containers and specify that the browser should not lay out and render those containers until needed. A second property is also available, which allows you to, which is contained intrinsic size, which allows you to provide a placeholder size for containers while they are under the effects of containment. This means that the containers will take up space even if their contents have not been yet rendered, allowing containment to do its performance magic without the risk of scroll bar shift and jank as elements render and come into view. This improves the quality of the user experience as the content is loaded. So this is something that I didn't know, and I'll have to dig into. But this is what I have to save. A guide to use container queries. Describes the basic aims. Okay, but this is not what we were looking for. Yeah, no, there's no information here about what we need. So how can I measure how much time does the browser take to execute a CSS directive? Let's call it directive. Yeah, not with JavaScript, I guess. No. Let's go to execution. We don't need that. Navigation and resource timings. No. Is there a way to measure the impact of on set all on CSS evaluation and subsequent rendering in the browser? Yeah, no. I thought about it, but not sure if it would be representative of what happens when you load the page. Use Lighthouse. Style recalculation cost. All unset removes default browser assumptions, so everything must be manually restored. Layout thrashing. If you're not careful, it may cause multiple reflows. Yeah, I did that, but the page should look the same, and yeah. So either we fix this page here and make it look exactly like this one, right? Or this means nothing. And also this is not representative of all cases anyway. How do we... yeah. Click away, click away, click away. Show me the summary. Rendering. Total 8 seconds. This has a much smaller total. It does nothing for a while there. Layout shifts. Layout shifts are happening here. And here there are no layout shifts. Probably, yeah. Yeah. So I'm trying to think about which route I want to go down. It already ends. I already answered myself. The curiosity I had is satisfied because it's trouble to use such a nuke. It will destroy a couple things that I'm not that eager to rebuild, and it's pretty clear that it has some impact on performance, but it's not clear if that's worth or not, even if we take away even if we ignore the fact that it's trouble by itself, because it's forcing you to restyle some things, and also that the original solution we saw here, where is it? This one is not sufficient at all. I can close this. I can close this. Response animation idle load. Yeah, okay. Performance APIs. Yeah, no, I don't need that. CSS containment, I will keep it open for further studies. Let's see if there are any other people on the internet considerations about unset all, any consideration. Let me zoom in a bit because it's unreadable for you otherwise. When you apply all unset to a CSS selector is reset. Yeah, we already know that. Usage priority. It has a high specificity and overrides all other styles applied in to the element through class ID, inline styles, or inherited styles. It does not affect child elements directly. No one's concerned about performance here, so we close it. Yeah, well, maybe I could. This is bad. I don't want to deal with this kind of banner, so there is no we just don't care. Performance considerations in CSS styling. Let's see if I can find some good article. Medium may or may not be good. Let's see. As web development evolves, so do the tools and methodologies developers use to keep up with modern demands. Bullshit, but we'll pass on that. One such innovation is CSS in JS, a technique that enables developers to write CSS styles directly within JavaScript files. This approach brings a whole new level of flexibility and control to styling. Yeah, in fact, the web is working better than ever, particularly in component-based frameworks like React and Vue. But with this power comes responsibility. Do not care about this. Potential for flash of unstyled content, because I mean, if that's not even, if that keeps being a problem, your approach is wrong. No, this article is lame. How can CSS slow down your website? Just like unoptimized images, unoptimized CSS can lead to slower pages and lower conversion rates. Now, notice how can stop the parsing of HTML. Yeah, can render block. The first pixel of a page won't appear until all CSS is parsed. Critical rendering path. Yeah. These are very high level problems that we usually fight. So I don't care about any advice on this, because the fact that the CSS has not to be render blocking, that if you have the CSS that you need in line, the above the fold CSS, the one that you need to render what's above the fold, and it's in line, yeah, it won't be cached, but you have a better performance because the page can render faster. You don't need to parse the CSS to start rendering the page. You can start rendering the page before, and even if you have another request for some other CSS that's not in this file, the HTML file, but in another file, it will do the round trip to the server and back asynchronously, so it speeds up. This is all clear. I'm very curious to know if there's anyone out there bothering about how fast are specific CSS commands, I mean not commands, properties, or as in the case of unset all directives, I should say, because it's telling the CSS engine that every style for every kind of element it has must be changed. So it's a directive, a command. Oh God. While CSS provides a wide range of properties to style web pages, some properties can be more expensive in terms of performance than others. Expensive CSS properties often require more computational resources from the browser, potentially causing layout reflows, repaints, or compositing operations that can negatively impact rendering performance. Here are some examples of expensive CSS properties that you should use with caution. Properties that affect the layout of elements, such as width, height, margin, padding, and position, can trigger layout reflows, which can be computationally expensive, especially on complex pages. Blur, drop shadow, and opacity can be expensive, of course. Animations and transitions, of course. Box shadows can be expensive, of course. Hardware acceleration, CSS containment, tree shaking. There are various tools and techniques available for monitoring and testing CSS performance, including browser developer. We already know this. The problem is load testing, conduct load testing, simulate various users. Seems like there's only one way to go, which is restyle the page to make it work and see if there's a difference. I must say that's very specific, and it does not represent all the entirety of the pages that are on the web, so it's not a great benchmark if you ask me. Optimizing CSS for large-scale applications is a crucial aspect of front-end. What we can do, because it's faster, is working on this page instead. So, which is the one, this one, when it's nuked. Oh god, I am too used to Neovim, sorry. Which one? This one is like this when we don't use the nuke, and completely broken when we use the nuke. We can when we use the nuke, we can take one more step and restyle it to get to this situation. So here you have an H1 which has these styles. Okay, so let's say we unset and then manually restyle H1 to be like this. This is also not exactly right, because you may restyle, this is not affected. You may want to restyle H1 to a completely different in a completely different way compared to what you get from the browser. But I mean, that's why there's there's not any general rule about whether this thing is very impactful or not. You must measure what's happening in your code. That's the only thing I can say at this point. Here we copy this style. So here we are. And here we copy this style. If I reload, did we uncomment? No. Please, 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 don't lag, please. Help me. If we uncomment everything here, we should get the exact same page. No, we don't, because body had display block and margin 8px. So body display, God, and then margin 8px, save. Okay, so now it's the exact same page. again, let's go here. And let's say we want this to be 768 pixels. Okay. If I do the test by commenting this, yeah, he's actually right. I don't know what I tried to accomplish that way, but it was stupid. If I do this and save and refresh, now we have the exact same page. Performance, throttling. Well, CSS selector stats are not that important, I gather. So record and reload. Is it gonna stop automatically? Yeah, 5 seconds. This one is by you. This is what happens when you use the browsers, the user agents styles. Major GC commit. What is this? Evaluate script. There's no reflow. There's nothing. Rendering took 1 millisecond. Okay. When you uncomment everything here, so like this, you still get the same. Oh, I did not do it in the right spot. God, don't tell me. Sorry, this was a waste of time. Your and mine as well. Okay. Let's check if the page shows properly. Yeah. 20 times slow down. Everything's fine. Record. Let's go. Profiling overhead. You can see that the page is very fast. If you compare it to other pages. Rendering is all concentrated. You have less than 1 millisecond to recalculate the style and less than 1 millisecond to lay out everything. So overall, rendering took 2 milliseconds. There's more system work than everything else. Here, we are gonna do the same, but we're gonna uncomment the style. Let's go. Yeah. What is this? Here the rendering took 4 milliseconds. The painting took 13 milliseconds. Here the painting wasn't even an issue. So even for this very small example, there is some difference. There must be. Let's focus on this first section here of 500 milliseconds or what? 1 second. Okay, first second. Let's focus on the first second. Here we are. If you compare this to this, you had much more work here than you had here. And that's because compile code triggered what? Is just lower. 20 times slow down, and this is 20 times slow down, no throttling. Yeah. There's the selector stats here. Oh well, it was here as well. So actually, but system 280 milliseconds, and here, I'm not trusting this result. 670, and here is 492. So for some reason the system calls were shorter here than they were here. Profiling overhead. What's this? Compile code. Why did it compile so much code up front? Is this because of... No, I don't think it's because of CSS, because I mean CSS scripting happens here, I guess. Parse HTML, yeah, happens here. So recalculate style here is 4 milliseconds. Recalculate style here is where is it? Here, less than 1 millisecond. I mean, it has an impact. I'm not ready to say that it has much of an impact than all the rest of the CSS you're applying. Elements affected 8. Elements affected 8. Select enables schedule style recalculation. Pending for 1.9, pending for 0.6. Two, and this is 5. Rendering is 5 milliseconds here. Here it is 2 milliseconds, and then you have 7 milliseconds of painting. This is strange, actually. I'd rather have this again. Here painting becomes a thing. Rendering is much slower. I really don't know if this is... probably this depends on the conditions of my computer's workload, because of course it's trying to measure times. So let's do this. Let's try it again now that it seems to be slower. Let's see. Still. Here system is much more on the same page. Scripting is much shorter in the original one compared to the one where I changed the style in the HTML, but I'm really not sure if this... Evaluate script. Which script? Can you tell us more about this? Evaluate script. Compile code. Call tree. There's no JavaScript, so I mean, what are you talking about? It's just the HTML here. The total time to get the file is the same, more or less. But the summary of the performance is very different. Very different. Rendering here took a lot more than here. Loading is, I'm not gonna say pretty much the same. It's faster in this one, so the original one. Scripting is faster on the original one, and I keep getting these results. Painting seems to be slower on the original one, but I guess that's because it's more painting and less rendering. We could put it that way. I don't know the difference between the two. Let me see. What's the difference between painting and rendering in DevTools performance? Here we have. Oh. I think the render and paint just both mean rendering the page show the DOM. What's the difference? Rendering events are about computing style. Rendering events are about computing styles associated with each DOM node. Cell recalculate. And elements position on the page layout. Paint category is about actually painting pixels and includes events like paint itself and decode image, resize image. In a nutshell, it's about inner structure versus appearance. If your page spends a lot of time rendering, this is because of the structure of its DOM and CSS, e.g. a large DOM tree, while significant paint times often mean the appearance of the page is affecting the performance. Significant paint times often mean the appearance of the page is affecting the performance. Some styles are expensive to paint, like, I don't know, blur, or an image is too large. Nice, okay. Layout refers to the process of constructing a rendered tree and using that tree to compute the exact position and size of each object. Painting refers to the process of taking the previously computed positions, drawing the colors to the screen. Layout has a notion of three dimensions: z indexes, structures, lines, boxes, flow, and parent-child relationships. In painting, we flatten all of this information down to 2 dimensions. The result of a paint is just a 2D grid of pixels and their colors. All the structure has been lost. Okay, I'm fine with that. So I'm still confused because I don't see why painting should take 6 milliseconds here and 1 millisecond here, being that painting is just the what we would call rendering in a game engine, so producing pixels out of the data structures we have. And you can find painting here, paint, layer root document. There's a pre-paint here, paint, layerize, another, okay, commit, and commit, pre-paint, layerize, and there, thread pool, GPU is working here actually, but again, the painting itself happens here, if you ask me. Also, this is called a long task actually. This one here says that the painting, this is still a long task. And also the one, no, well, this is the first one. Then you have the HTML parsing here. and paint is 0.16 milliseconds, so I really don't know why it's summing it up to, well, there's this task here, commit, hit test, layerize. I don't know why painting here amounts to, it's 0 milliseconds actually. Well, no, let me do this. Probably I'm just being stupid. Let me check. I'm not. Here it's counting 6 milliseconds for painting, and here it's counting just 1, and I really don't understand why that should be. I mean, Mr. Painting happens mostly. What are these? There's another paint here. Commit. Are commit part of the painting? Yeah, yes, they should. They're green. What does commit mean in DevTools performance, and why is it a paint event? Enable advanced paint instrumentation. Let's see that. Let's take a look at that. Which is slow, but we don't care. Let's do this before upfront. Yeah. No, we commented the code, so let's do this before. And then we uncomment the style, save the page, and do the same test here. Is it right? Yeah. Well, let's let it be open. Painting here took a lot, and here took even more. Is there a way to see some more data, or enable advanced paint instrumentation slow? I want to know what this thing does. I hope to see more data about painting, but probably it does, but and that's why commit is slow, because it's saving down data about this, but you know, I don't see anything about painting in any tab. So tell me more. This is CSS selector performance during calculate style events. In your performance recordings, some of these long-running tasks may be recalculate style events. A recalculate style event tracks the time it takes for the browser to do the following. Iterate through the DOM elements on a page to find all of the CSS style rules that match a given element. Compute each element's actual style based on the matching CSS style rules. Okay. CSS styles need to be recalculated whenever the applicability of CSS rules may have changed, such as when elements are added to or removed from the DOM, and elements' attributes are changed, such as the value of a class or ID attribute. User makes inputs such as a mouse move or a change of element focus, which can affect hover rules. Long-running recalculate style events can be problematic for performance and can be a cause of long presentation delays that affect your website's interaction to next paint. If you find long-running recalculate style events, you can use the selector stats tab to understand which of your CSS selectors is taking the most time and slowing down performance. The selector stats tab provides statistics about the CSS rule selectors that were involved in one or more recalculate style events within a performance recording. To view the statistics, you have to record a performance trace. So elapsed is the amount of time the browser spent matching this CSS selector. This time is given in milliseconds, where 1 millisecond is 1000. Yeah, thank you very much. The number of elements the browser engine attempted to match with this CSS selector, the number of elements the browser engine matched with this CSS selector, the ratio of elements that didn't match with this CSS selector to the elements that the browser engine attempted to match and which required the browser engine to use less optimized code to match. The ratio of the elements that didn't match to the elements that... Yeah, okay. The CSS selector that was matched, the CSS style sheet that contains the CSS selector. Yeah, well, nice. But the time spent in recalculating style it's just that they won't tell you, they won't break down the thing. Focus on the CSS selectors that took a long time to calculate, which the browser attempted to match many times, which the browser didn't actually match many elements with, which have a high percentage of slow path non-matches. Again, what was the slow path non-match? Where is it? Didn't match, and which required the browser engine to use less optimized code to match. Okay, but this is all about matching. I'm pretty positive that star will, of course, match all the elements, and at least that's what I've naively done if I were the one to program the CSS engine. It would kind of be of for a star operator there would be a specific implementation that cycles, loops over all the elements in the DOM, which must be conveniently stored. The pointers to them must be conveniently stored into an array. So the time it takes to go, I mean, I think I will explain myself better if I draw it. And at the same time, I have nothing set up to do that, but while Krita starts up, I will connect my drawing tablet to the laptop. Oops. Sorry, guys. Sorry. Come on. Let's see. Please start. Thank you. New image. No, not 1 pixel by 1 pixel. No, that was a mistake. 1920 to 1080. Create. I'd say in the memory of the browser for that tab where we loaded one page, let's say we have this particular DOM, right? This one. Where is it? This. So this. Okay. So you'll have a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 nodes, something like that, right? Let me change the, yeah, much better. Layer is locked. Why is that? What did I touch? Unlocked layer. Thank you. We said 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Each box represents a data structure. There's somewhere in the random access memory of your computer where all the data about the style of your nodes is stored. So they're also probably kept in an array, and I'm not entirely sure how they are managing the fact that each node could have many instructions. That's beyond me. Instructions, I mean keys, I don't know how to call them, all of these, right? I don't think, I hope not, at least, each one of the, well, actually, could be, each node has all of those set, and many of them are set to 0 or stuff like that. If that's the case, these structures here, let's say this one is the one for HTML, this one is the one for head, this one is the one for first meta, so let's call it meta 1. Then there's meta 2, this one, right? And so on and so forth, so title and stuff like that. Each one of these has a lot of values stored inside. When I specify this, in my CSS code, so I say for each element in the DOM, do this, which is go over every property and reset it. Make all elements in the DOM stupidly the same. They are all the same. A div won't be different from a span, that won't be different from an image, that won't be different from an HTML tag, that won't be different from a head tag, and so on. This the operation of clearing every property and making it reset will take a constant amount of time, meaning that every element in the DOM will cost the same. Let's call it C, the cost of this operation of unsetting everything from one element in the DOM. If we loop over every element in the DOM, we will just spend C or something very near to C. I don't see it being much more in one element than the other, because if it's true that everything, like you see, every attribute, every style exists for each and every element in the DOM. Let's say these are 200 styles, attributes. You have to have 200 operations here, so it will cost C. You will have also 200 operations here. I don't think that in the case of this element here, which has from the user agent style sheet, it says that 1, 2, 3, 4, 5, 6, 7, 8 properties are set, and so resetting means resetting 8 properties, while doing the same for I don't know, body means just resetting the 2, which would mean that some elements are more costly to reset than others, but still you could overestimate each and every one of them with the maximum cost for the longest element you have. I'm positive that that's probably constant, the cost between one and the other element. Anyway, that cost is of course multiplied by the times you have to do that operation, so by the number of elements in your DOM. So the bigger the DOM, the longer the time to reset everything. And that's one reason why this thing here should be more costly in bigger pages. But all in all, doing this, I don't expect it to be that heavy. Still much heavier than unsetting a single property, because if you have 200, 2000 properties, I'm curious to know how many properties there are. CSS attributes, properties, how many there are. Properties, I was right, it's properties. 259 of them, yeah. The source code uses MDN. I would have probably looked at MDN, where some quick query selector all handiwork in the console yields a different number, 584, so it's more, maybe. But oops, that's full of selectors, at rules, and other stuff. Their reference only lists 72, but says it's incomplete. W3 schools lists 228 of them. HTML dog lists 125. Our almanac has 176, and I know we omit stuff on purpose. We file margin left under margin instead of making its own entry. The horse's mouth, 520 distinct property names from 66 technical reports and 66 editors' drafts. The horse's mouth meaning W3C. Both proposed and standard. A lot. Okay, so if you have a selector and then a block of styles that goes and changes a small amount of properties, it will cost a small amount of time. If for each node you have to change all properties, or at least loop over all the properties for each node, and check if that property is already the right value and reset it. If not, I think it's probably just faster to reset it, because you're there and you don't have to make a check, which is costly. You know you're resetting, you're just replacing the style with the default one. I'm also thinking that you might even do some lazy stuff, like keeping somewhere a copy of kind of unstyled DOM element, and then just point like a flyweight or a union in C. It's not really like that, but let's say you have one of these somewhere else in the random access memory with all the properties, and they are all set to the default value. And the moment you say this thing here must be, you call this in particular, this, you say I reset it. Instead of resetting this copy, you just discard it. Well, no, you won't discard it because you'll need it later, but you can just point to this, and when anything will be changed, you will at that moment copy the content of this inside here and then change the single thing. But well, you're just delaying the copy, so you're probably just copying from here right away. Not even copying from here, probably just it's in the code what's the default for that element, for that property. So yeah, anyway, this will be much more expensive than, say, setting the margin of a single element, because setting the margin of a single element means just touching one property, and the properties are surely saved to be random accessible, meaning that changing a margin or changing a box shadow doesn't take a different time. So yeah, surely I expect it to be more costly. Not that much on a modern computer. Still, there's a hidden cost, that is that after we did all this to reset everything, we then have to go and add some CSS to get back to the point we were before, minus something, of course, because you want to get to what you want, not to what the user agent style sheet was telling you. And so you'll do some more operations to style that particular element, that class of elements, that group of elements, and so on and so forth. While you could have just styled the elements to start with, and live with that without looping on all of them. They might be a lot. I have this example. If you go to my this homepage here and you go check how many elements there are in the DOM, it's a lot. Let me do this. Let's see. Seven seconds. Quite a lot. Could be better, but 1418 elements. If each one of them actually has they could have wrote down 634. So let's say you have to unset all, okay? You loop through 1418 elements. Each of them has 634 properties. You will have to do almost 900,000 operations just to reset the styles in the DOM. Pretty much. It's probably slow. I mean, these are not the number of operations the CPU has to do. It will be a multiple of this, and it starts to be not ideal. I'm trying to think if there's a way to establish if I'm saying right things or not. I should go and see. Let's see how many cycles does a move operation take in a modern CPU, which is very generic, but still. God, open it, please. No. move. Sorry, but isn't it move the operation that we need? Don't tell me there's no such operation. Sorry, mov. SIMD floating point. General data movement instructions. Mov. Between memory and registers. The move instruction performs basic load data. Yeah. Yeah, we don't have the cost of operations here. Yeah, no, we're going down a loophole that I don't want to explore right now, even because it's already 10 minutes to 11 p.m. here in Italy, so we'll have to wrap this thing up. I was thinking, yeah, no, I think we'll call it a day, meaning that I'll go here and say 2 notifications. Let's say that I kind of have some results based on very limited testing. It's just what I was able to about, maybe let's say about the CSS nuke. It's just what I was able to understand from the performance. Well, let's say based on very limited testing. Unset all is somewhat costly, but I don't know if I'd call it dramatic. Dramatic, is it a word? Do I write it like this? Yeah, no. Well, wait a sec. I don't know if I'd call it too expensive. It sure depends on the size of the DOM. Actually, it's not easy to measure how much it takes to execute because well, we could do that. We could do that. Let me do this. There was the thing about using performance now measurements and doing the doing the thing, yeah, doing the DOM content load or CSS application here. Let's do this before jumping to conclusions. I mean, I know it's not exactly the same, but DOM content load or CSS application here. Oh God, please. Sorry, here, change CSS from JavaScript. Better. Call unset all from JS. Actually, I'm too tired to think of a solution by myself. So let's say what JavaScript code could well, I could load trigger, could execute write some JavaScript code that dynamically executes all unset, not unset all, I was wrong the whole time, as if it was read from a CSS file or in a style tag in the HTML. Nice. This is it. That's fine, because this should tell me how much time does it take. This is not the file I wanted to work on, but still it's okay. It was this one. He is not here. It's let's go here, let's go here, close this one, reload this one. Let's see, what does it say? Performance measure, duration, is this milliseconds? Start time, yeah, I think it's milliseconds. Let's take away this, reload console. It started at 89 milliseconds and it was less than 1 millisecond. If this is milliseconds, I think it is. Performance measure, performance measure MDN. Abstract interface for performance entry objects. Yeah, okay, well. Start time, timestamp. Timestamps are in milliseconds. Yeah. The time given in milliseconds should be accurate to 5 microseconds with the fractional part of the number indicating fractions of a millisecond. Which means it's actually very fast to apply that. Let's say we do this here too, but I really want to open this guy here with NeoVM because if not, I'm gonna explode, break into pieces. Here it is. X. So let's say I do this. Go to CD mount X. Is there an X? There is no X, but it's in D, if I'm not wrong. No, it's not. Oh God, I'm tired. It's here. It's here. CSS new. Mamma mia. Okay. Here we're gonna comment this again. Same mistake as before. And do this instead. We move to this one, copy this thing, move to this one, paste it, and style that text count. Why did I said to copy? Okay, I know why. Copy. Oh, that was a mistake. This guy here. Style is not the thing we need anymore. We need to put here some script tags. Performance.markStart. This has to change, and we will use the very sexy multi-line strings and copy this thing here and paste it here because I like it much more. Of course, we have to go to this line, delete everything, and that's about it. Now, if I refresh the page, of course, let's remove the throttling. And the console is telling me that it took, again, less than 1 millisecond. Even if I throttle, it's taking 37 milliseconds. Let me see if I change the size of the DOM by just adding more and more elements of the same type. If it's I mean, naively, I'd expect this to take 4 times as much, but for some reason my gut is telling me it won't happen. It was much faster actually. Is it taking, now it's 20 milliseconds, now it's 15. we should execute it a lot of times in a row and see. 13. 1.3. Very funny. Stop, please, please, please. This was a mistake, please. Let's do, well, let's do this. Rendering 3 milliseconds, painting 1 millisecond. This tells me that we really don't have any big information about parse HTML, evaluate script, recalculate style, layout. And the console says it took less than 1 millisecond. So I'm not really sure. I'm not really sure. Three milliseconds. I should turn everything off, do it off screen with just the browser, with just that tab open, every other program in the computer not running, because this is too volatile, and it's not telling me anything about the result. Still, removing this part, sorry, this part here won't give me huge changes in the execution time, I guess. Now it took a lot more. 12 milliseconds and down to 5 again. So it's like cold starts are making it slower. Kind of, actually. So I don't know. I really don't know. I feel I can't answer this question right now. If it's to be avoided based on performance reasons, due to performance issues. The numbers I got in the tests were kind of let's say this and reply to myself and say for a very small page with just an H1 and H2 and a P, you can that are for a very small page with just an H1 and H2 and a P that are reset and then restyled manually to appear agent style sheet and B that are reset and then restyled manually to have the same style they first had because of the user agent style sheet, you can see some differences longer in rendering, but almost nothing. It's almost nothing if you rely on less than 1 millisecond. If you rely on the user agent style sheet, it's a few milliseconds if you call all unset and then restyle it yourself. This while throttling to have a 20 times slower how's it called, a CPU using a 20 times CPU slowdown to simulate being on mobile low end devices. Again, it's not clear how this would, well, am I doing this wrong? Oh no, okay, it's right. Now I have to answer to this. Still doing the same on a bigger and more complex page might yield very different results, but I wasn't able to replicate it. I wasn't able to do so because the pages I have at my disposal break, of course, if I call all unset. So what's being rendered ends up being very different, and I get huge differences. And I get very different execution times. The main point I wanted to report, though, is that the all unset approach may be too naive for is plus style let's say this style script display none is too naive for Chrome already. Didn't even need to test it on multiple browsers. I'm saying this because let's say and that's something more, and then where is it? You can see my response here. What the hell? What's going on here? What's going on here? What? I kind of have some. The last message got lost forever. I can't find my posts on my page. How's that even possible? Please, Twitter. Let me see what I show this. Okay. Okay, here we are. Respond. Where is it? Here. In here. As you can see, the user agent style sheet requires display requires to let's say the line, because without it 8 to 8 at line 8 to 8 the user agent style sheet sets display none to many more elements than just style and script. It happened to me that the what was it? The title, yeah, the title was being rendered in the page. So I'd say it's probably better to avoid nuking. So like this. So my conclusion, a few hours on this, is that it's probably better. My opinion is that it's probably better to avoid nuking everything and build how do you call it? Every time it defies me. Greedy. CSS bomb that only overrides what bothers you. Avoid nuking everything and build over time. Over time, I don't know if it's English. And build nel tempo in inglese. Over time, is it over time? Over time, yeah. And over time, build a greedy CSS bomb that only overrides what bothers you, what you found bothers you. I'd start from titles, paragraphs, anchors, divs, titles, paragraphs, anchors, divs, buttons, the most common elements. Didn't have time to explore. I didn't have the time to explore the effects of the nuke on HTML5 elements like SVG, canvas, audio, and so on. But I read worrying things, but just looking at the GitHub page I linked above, you can see that even the calendar input element relies heavily on user agent style. So I believe HTML5 elements I believe HTML5 elements will also suffer from such a radical approach. Here we are. Okay, so we made it. I kind of forgot I was streaming at this point. Pretty particular stream today. If you will have the stomach to watch it till the end, thank you very much. If not, no worries, from the next time, so on Wednesday at again 9:30 p.m. Central European time, which should be 12:30 p.m. On the Pacific time, and 3:30 p.m. Eastern time. We will stream again and work on the e-commerce as we used to last 2 or 3 times or 4 times, I don't even remember. Thank you very much again, and see you soon. Goodbye, goodbye, goodbye. If I can find the button to stop the stream. Yeah. Bye bye.